Hello friends, this video on determinant part 27 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 26. Take one more theorem. The theorem says that square matrix is invertible if and only if it is non-singular matrix. I told you the reason why we are studying non-singular matrix is we know the theorem that the square matrix is invertible if and only if that is a non-singular metric. We'll take some examples where we have to find inverse if exists for this particular matrix. So to find the inverse, first we have, if this is A, let's suppose, the first thing is we have to find determinant of A. If determinant of A is 0, that means inverse doesn't exist. So let's find determinant of A. There is nothing but 2 into 3, that is 6 minus 4 into minus 2 minus 8, and that is 14. That is not equal to 0, so I can say that inverse exists. Second thing is I have to find adjoint of A. For adjoint of A, I have to find all the cofactors. A11, that will become 3. Similarly, A12, that will become minus 1 into 4 minus 4. A21 will become minus 1 into minus 2, that is 2, and A22, that has become this guy 2. So I'm just using shortcut because I assume that you know how to find determinants. If you don't know, please watch my earlier videos for the same chapters where I have taken some examples where we found the cofactors in a little slower manner so that you can understand it. So the adjoint of A will be nothing but this A11, that is 3, A12 minus 4, A21 2, and A22 2. This is the adjoint of A. A inverse I know is nothing but 1 by A determinant into adjoint of A matrix. So this guy is nothing but 1 by 14 into 3, 2 minus 4 and 2. So this is my A inverse. Very simple. I just found adjoint of A, I found A determinant, and the inverse is nothing but 1 by A determinant into adjoint of A. The similar question, instead of 2 by 2, we have 3 by 3 matrix. Little lengthy. Here we have to find inverse if exists. The first thing we have to find, if this is A, let's suppose, the first thing we have to find determinant of A, and that guy comes out to be 1. I'll take these I'll find determinant along this because I have two zeros here. So 1 into 5 into 2, 10 minus 0 plus 0 plus 0. So that is 10. Determinant of A is 10, that is not equal to 0. So determinant of A is 10, that is not 0. Correct? So I have A determinant. So that means I can find inverse because determinant is not 0. So first, next thing is I have to find adjoint of A. Adjoint of A, for this I have to find all cofactors, that is A11, A12, A13. You can find all these, so I just write the values. A11 will come out to be 10, A12 will come out to be 0, and A13 will come out to be 0. Similarly, other values you can find. I'm just finding it because you can do it, it's very simple. So adjoint of A finally will come out to be 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. So if you're having difficulty in finding this, try once with your own. If you're having difficulty, watch my previous examples where I have told how to find determinants or how to find adjoint of matrix, and thus you can get adjoint of matrix. Once I have adjoint of matrix, A inverse is very simple, 1 by A determinant into adjoint of A. 1 by A determinant is 1 by 10 into adjoint of A is this guy. 0, 0, 2. Exactly same thing. And that is my answer. So I found the inverse in a very simple way. This is also one simple example but lengthy one. So here you have to verify that AB inverse is equal to B inverse into A inverse. So what we can do is we can find AB first. and then we can find adjoint of AB, and then we can find determinant of AB. Then we can find AB inverse, that is nothing but 1 by this guy into adjoint of AB. Similarly, we can do the same thing for B. I can find adjoint of B, and then we can find determinant of B. I'll say B inverse is nothing but 1 by B into adjoint of B. Similarly, for inverse of A, I can find adjoint of A. I can find determinant of A, and then I can say A inverse is nothing but 1 by A determinant into adjoint of A. So I have AB inverse, I have B inverse, I have A inverse. Then I can prove that AB inverse, whatever comes out to be, is nothing but product of these two matrices. You can do it, it's very simple. The example says that there is a matrix 2 by 2, 3, 1, minus 1, 2. You have to show that A square minus 5A plus 7I is equal to 0. Also, we have to find A inverse. Showing this is very simple. We have done a couple of such examples in the matrices chapter. So we can do this here also. We have to find A square first. Is nothing but 3, 1, minus 1, 2 into 3, 1, minus 1, 2. Take the row, take the column. This becomes 3 into 3, 9, plus 1 into minus 1, that is minus 1. 3 into 3 is 3 into 1 is 3, plus 1 into 2 is 2. We'll take this guy, minus 1 into 3 is minus 3, and 2 into minus 1 is minus 2. Same thing, minus 1 into 1 is minus 1, and 2 into 2 is 4. This is nothing but 8, 5, minus 5 and 3. So I have A square. So let me just try to prove this. A square minus 5A plus 7I is nothing but A square is this guy, minus 5 into A is this guy, plus 7 into I is this guy. So if you solve this, what you get? 8 minus 15, right? 8 minus 15 plus 7, the first element. The second element is 5 minus 5 plus 0. Third element is minus 5 plus 10 minus 5 this guy is minus 5, this is 1 actually, minus 1, minus 5 plus 5, and this guy is 3, minus 5 is minus 3, this guy is 2 actually, 3 minus 10 is minus 7 plus 7, 3 minus 10 plus 7. So this is nothing but 0, 0, 0, 0. Correct? So thus we have proved this equation. First part is gone. Very simple. Now we have to find A inverse. That's the tricky part. The trick here is when we say that A square minus 5A plus 7I is equal to 0, that means if I multiply everything by A inverse, left hand and right hand side, so what I get in this case is an equation in the form of A inverse. This becomes A inverse into A square is A, minus 5A into A inverse, that is 5I, plus 2I into A inverse is 2A inverse is equal to 0. Or I get A inverse as nothing but 5I minus A by 2. Very simple now. 5A minus, sorry, 7I. 7A inverse. So by 7. 5I minus A by 7. So this is very simple now for me. I can find 5I, that is 5 into 1100 minus A is nothing but this guy, 3, 1 minus 1, 2, the whole thing divided by 7. So this becomes 5 into 1, 5 minus 3, that is 2, 5 into 0, 5, 5 into 0 is 0, 0 minus 1 is minus 1. 5 into 0 is 0. 0 minus of 1 is 1. And 5 into 1 is 5, minus 2 is 3. The whole thing divides by 7. So that is my answer. 1 by 7 into 1 by 7 into 2 minus 1, 1 and 3. This is my matrix. So what I have done here is I have one equation. The same equation I just multiplied with A inverse, and I got one equation in the form of A inverse because I already know the value of I and A and solved it to get the value of A inverse. So instead of going by a lengthy way of finding determinant, adjoint, since I already had this equation, I leverage this equation to find the value of A inverse. Almost similar question. Here also we can do the same thing and find A cube, 6A square, 5A and prove that that is equal to 0. And to find the value of A inverse, what we can do is we can multiply both sides by A inverse. So what we get, A inverse into A cube minus 6A square plus 5A plus 11I is equal to 0, or I get A square minus 6A, because 6A square into A inverse is 6A, plus 5I plus 11A inverse is equal to 0, or I get A inverse is nothing but minus 1 by 11 into A square minus 6A plus 5. We put the values of A squared, 6A and 5I, added and get the answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.